Hello everybody! So we're going to try something a little bit different today. Unlike the normal streams, we're going to take some time today and we're going to record just a block, more or less continuous, of going through and trying to do something similar to what we've been doing on the Tuesday streams. That is, I'm going to take a look at CVE, we're going to try and figure out exactly what was happening in it from the very limited explanation, and then we're going to see if we can try and exploit it. The idea is that having these recorded ahead of time should make it a little bit more interesting for people to watch, because unlike a stream, now I can just go straight through and do research, as opposed to also talking with people. While that's great, in some cases I learn a lot from the audience, there's some downsides to it too, because I frequently get distracted. So, we're kicking this off today. A few days ago, I had put out this tweet asking if anybody had any recommendations, because ideally I want a CVE that's relatively new. Something that doesn't have a ton of current research into. And I want it recent enough that it seems interesting still. Like, while, I suppose if you go back far enough, like, taking a look at one of the, like, very early 2000 CVEs, it might be interesting to take a look at some of the differences. For the most part, we want things that are new because those are more likely to be important for security reasons. So I got a few responses from a few different people about it, but the one that I landed on that I actually think is going to be really interesting is this one right here. So we're going to take a look at CVE-2019-9956 that this individual recommended, and basically what this is, not basically, it is an ImageMagick CVE. In particular, if we go through and click through a couple times to actually figure out what it is, there's this stack buffer overflow in pophexpixel.ps.c. So, for the most part, like, stack buffer overflows are relatively uncommon in modern software. Especially ones with, you know, good, testing practices, because, for the most part, these are actually detectable statically in a lot of cases. So, they're also very interesting for exploitability reasons. Depending on whether or not there's a cookie in place, this may be completely non-exploitable, or it might be very, very easy to exploit, depending on exactly how it lines up. So, it's a little bit risky of a choice to make for this first recording, just because there's a non-zero chance that we take a look at this, and we get, you know, an hour or so into this recording, and you find out that, nope, you're gonna bash a stack cookie in the way, and it's going to crash, and that's the only option. That there's a buffer, then a stack cookie, and we can't leak out that stack cookie to have it loaded up. So, with that said though, we're gonna take a look at it. Hopefully it should be really interesting to take a look at. Let's get started here. So the first thing we're gonna do is, this is one of the ImageMagick utilities. So, let's start by, let's think about this for a second. Let's actually SSH into one of the real Ubuntu machines. Let me pull that up here real quick. And the reason we're doing this on a real Ubuntu machine as opposed to just the Hyper-V setup, is because for at least some things it's going to act differently. So let's at least get this staged and ready to go. So we're coming in here. And because we're good developers, we're going to make a Git repo for it. Okay. So first things first, let's actually get ImageMagick, because I don't think I have it on here already, right? Yeah. We want the ImageMagick convert.
You've got me saying words in my head, filling my mind with these images, yeah. And it's the way that you look at me, makes me feel like I can't breathe. It ain't right, 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 it ain't right, 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 it ain't right. Oh no, it ain't right, 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 it ain't right, 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 it ain't right. Oh no, it ain't right, 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 it ain't right, 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 it ain't right, 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 it ain't right. You've got me saying words in.
Okay, so the version that we pulled out of the repo is actually ancient, isn't it? Yeah, we want a newer version, don't we? Okay. So what we just did there was we pulled down out of the repo ImageMagick, and it looks like if we're going to do this for real, we probably want the actual repo version. So we're going up a level here, just so I'm not cloning a repo into another repo, because that can lead to some ugliness. Like, I don't think it's a problem most of the time, but it's possible to get confused about what directory you're in and accidentally commit into something you don't mean to and lose results because of it. At least my experience is that it is fine in terms of actual functionality, it just can be confusing for me when there are nested repos. Now we have to take the time to actually clone things. Oh, here we go. Okay, so we probably need to do a configure missing requirements. Actually, now that I think about this, I think we actually need to go back a little bit, don't we? Because this is patched in current, so... I don't want this version. This version looks good. Once we verify that this will actually build, we're going to revert to an older version and configure again. So, to explain that a little bit, we checked out the current version out of the repo, which has a fix for the bug that we're looking at. So it doesn't make much sense for us to build it and try it in order to work if we're just going to find out in a few minutes that it's not exploitable. It's not vulnerable to the bug because they pushed a fix for it. So we're going to roll back to an older version real quick, at least once this finishes. The reason we're letting this finish is just because it's going to verify that we have everything on our system. And I don't want to have to sit through this much. Well, no, actually, you know what? We're going to have to do it either way, so... No, I have one. Okay. So we've now actually checked out the right thing that we intended. So we're going to have to configure it again and do it again. is always one of the kind of annoying parts about doing some of this research is it can take quite a while. I guess this is not as easy to build as I was hoping it would be. We have a README, don't we? It helps if I could type properly. Okay, what is it? Don't care, don't care, don't care, don't... It's the same thing. Quick start, that's probably what I want. Okay, download the appropriate binary. That's not at all what I'm doing, is it? There's no there's a build directory, but that was just created. That would have actually read the error message, wouldn't it? Look at this, and it looks like I also need autoconf. Okay. Oh, error messages. It'd be nice if I read those, wouldn't it? Yeah, like I was saying, one of the more annoying parts about doing some of this research is that you have to build everything, and building things can take a while. I mean, that's just the nature of software, right? Like, we have all of these dependencies, so you have to pull down all of them, you have to get them all set up and built, and it just takes forever. So, okay, so hopefully this is the last thing we actually still need to download. So given that it worked, we're going to make with J9. J9 is telling it to use 8 cores, 9 cores, something like that. Or to tell it to use 9 processes, I believe. Or 9 jobs, which means that since I have 8 cores... I actually don't know how many cores I have on this system. It might not be 8 cores. I'm used to using an 8-core system, though. But anyway, the point here is that I'm telling it to start 9 jobs, which means that there should always be 1 more than the number of cores I have, so that all the cores should be working more or less as fast as they can be. At least that's the general wisdom I've been told. I don't know how true it is, but it sounds plausible, so it's what I kind of go with whenever I'm building stuff, and I want it to go fast. Of course, the downside is that it's a maximum of 9 jobs, so in the current case it looks like it's running configure again. I don't know why. I had assumed that I would have to run it. And it's probably blocking on everything else because it has to configure everything first. Once we get to some of the actual building stuff, it'll hopefully go a little bit faster. Guess we're actually compiling things now. I'm not entirely sure what a .lo file is. Is that like a local object as opposed to a normal .o, which is an object file? Oh, and we wait. Let's check out this other machine. I want to build it on here too. Oh no. Oh. Did you succeed? Where did you go? Okay, so it looks like that actually worked. And if we go back, there's a proof of concept they have that should... Well, we didn't build it with whatchmadoober, but so according to this, I should be able to do a magic convert this thing okay. This is not going to work, which is why we were setting up this machine. Is it looks like this is indeed going to be at least kind of exploitable for us, which will be exciting. No, we already had this configured. Oops. Okay. Okay, that's been pushed over here. Thanks. Okay. Notice it's a little bit faster on this machine because the WSL latency thing. I think I've complained about it on stream a couple of times. The file I/O is slower. It's enough that a lot of the time you can't notice it when I'm like editing files and things. But when I'm trying to like build software, it's noticeably slower, which is unfortunate. Like it's the one thing that I have issues with using WSL is just that extra file I/O overhead. Basically, as far as I can tell, it takes probably 5 to 10 times as long to open every file, which for most stuff doesn't matter. Like, oh no, the 2 milliseconds it takes took 10 milliseconds instead, and you can't even notice it. But when you're opening, 100,000 files, then suddenly that's enough of an overhead that you can actually notice it. So, and now we wait again. While waiting here, I should actually fill out my to-do list here. So once we do this, so just to go through here real quick what we're going to be doing. So we're going to verify it on 1804 once it finishes building. We just need to make sure it crashes. And after that crashes, we can open up in a debugger and actually take a look. So the fact that it's aborting leads me to believe that we're probably ending up hitting a stack cookie, because most compilers are going to throw one in there, which is going to make it tricky. So let's actually do that too. So we have this hypothesis that it's a stack cookie. We're going to open it up, and so once we verify that, we're going to look around a little bit and see if there's anything there. After that, we're going to open it up in probably Ghidra, just because I'm getting relatively comfortable with Ghidra now. I've used it on... So I used it for Zero CTF when I played... Was that only last weekend? Wow. It's been a busy week for me. When I played it in Zero CTF, I've worked with it in a couple of other things that I've, like just little side projects to reverse. For manual reversing, it's quickly becoming a tool that I like quite a bit. So hopefully we're able to get this working pretty quickly and take a look at it. Okay, we're going to reverse it a little bit. So what I mean by exploitability paths is that basically we don't actually know if this thing is going to be exploitable. Even if we have a crash, if we're crashing because there's a stack cookie there, and like I mentioned at the start of this, there's a non-zero risk here that just because of how the compiler dropped stack variables in place, we have our buffer, we overflow it. The very first thing we overflow is a stack cookie, and then we immediately return. Like, that's a thing that happens, and there's a very non-zero chance that we're going to end up in that situation, and we've got no real path forward. So we're basically going to get this opened up in Ghidra and see, are there any paths towards exploitability? Opening it in GDB and looking at the crash is going to give us a little bit of information. But even if it doesn't look exploitable in the crash, it's possible that we can affect something nearby that's going to be useful. We'll see. Because basically the hope here is that even if the path that we take immediately returns, maybe there's another path. We have to set up a slightly different state or something that will hopefully let us do something else. But we'll see. Oh, I guess while we're waiting here, we'll also drop in here. So we're using put in there just the version we're doing here. So it's 70827 that we're actually building. Just like having it there as a reference. Okay. Here's a real trick, great. Looks like it works. So what does this actually look like? Okay, well, at least this report had some more useful information. So, to stack buffer overflow on address here. And it gives us our PC. So we're gonna do this, we're gonna break on this address. What else are we doing? We need to set args to be convert this thing ./test.ps. We're gonna run it. Sure. What happened? Yeah.
Even if your heart wants to die, all of the pieces that made us are trying to keep us from makeups. You've heard things you can't ignore. Whispers from the outside drown your thoughts. You gon' believe
How does this work? But this is not actually the binary.
You only wanted one thing. You gon' believe that. You only wanted one thing.
So what we're doing here is we're using strace, and I'm being lazy here. So we used magic with those arguments. So at some point it's going to actually open a real binary.
I'm on a plane to fix these scars. No matter the distance, you're still carved in me.
Oh, it's going to use ImageMagick.
Need assistance
Okay.
like I gave you. I know if you're listening, I'm no angel.
No.
You've heard things you can't ignore. Whispers from the outside drown your thoughts. You won't believe that. Where were they when you were flawed? Waiting for me to fall overboard.
How does this work?
Think you gon' believe that.
Okay, it looks like it's going to call
Only wanted one
this.
thing.
It's a little weird, but okay.
I just wanna hold you again, but you don't need that. And if you haven't learned from me,
This is a little trickier than I was hoping it would be. Of course, they're setting up a wacky environment like this. Okay, So
You only wanted one thing. You gon' believe that. You only wanted one thing. You gon' believe that. I just wanna hold you again, but you don't need that. And if you haven't heard it from me,
sets up an LD library path.
one thing.
And then it will run the program, the arguments. Okay. So I guess if I set up the environment, this will work. What's with the latency? Okay. What did you say this was? This thing? Where are you? Okay. It's not in utils, it's in... I'm typing this wrong. LD library path, right? LD library path. Oh, we have to do a full name, don't we? Interesting. So we're still not opening this even. Well, do this. No, I cannot. Error while loading shared libraries. Helps I put the... So that would actually do it properly. LD library path is equal to this. I'm going to do utilities.lib magic convert stack buffer overflow test.ps. Okay. So we're getting closer. Oh wait, nope, I just can't type. Okay, that worked. So I need to think about how exactly to do this now. So we want to make it... Actually, let's check this real quick before we get too far. Utilities.lib magic. Does this work? Ah, it does work. Okay, this actually tells us a little bit about where we're at. So, there we go. This is what we were looking for. It looks like we indeed did just trample the stack. But it looks like we're going to be in a weird situation here. So, they said we're hitting this raise, and none of this has been dereferenced yet. Tells me that the raise is almost certainly a stack cookie, right? Wait, no. So we're in write PS image. We then call pop hexpixel. Hexpixel. What does the report say? Hexpixel. I mean, this is exactly, it's not exactly, but it's very similar to what we're seeing right now, right? That we're in pop hexpixel and that we're trying to get stuff out of it. Is there anything else useful in this trace? I'm just going to close this real quick and make sure that everything's cleared out. Log out. Okay. So, pixels we're failing on. I think this is built poorly, isn't it? Because this will almost certainly run off the end of a page here is the reason that it's failing. So I suspect what we're seeing here is actually that the crash is not the version that it could be. Which makes sense. They're not giving us the easy to exploit version of it. But there's lots of 30s here, which is good. Well, let's take a look at this real quick. What does this thing actually look like? Oh, interesting. So, this is very simple. It's a very simple bitmap. Oh. So if you look at what it's saying here, it's 1 pixel by 35,841 pixels. So I'm gonna check to see like an 8C01 in here. 8C01 right here. I'm not gonna do this right, am I? Yeah, I'm not gonna do this right. I always have to look this up, don't I? Ah. Okay. Okay, so we're going to change this from 8C01 to 8CO. Now where are we at? Interesting. It's interesting. I'm kind of surprised. I was assuming that this was going to change things, that we wouldn't have this out of bounds read here. So my assumption is that that's what's happening here. A sig11 is a sig seg v, right? Come on. Why am I getting all this latency? SIG11 is a seg B, which is a seg call, which means we're getting an out-of-bounds read, which, if we look at this thing, we see that this is, we're trying to get an out-of-bounds read here. Yes, we bashed the stack and wrecked it. Like, we have wrecked our stack. Like, really wrecked it. Doesn't matter if we can ever get, a return to happen. So, did I make this work right? I did make that work right. Let's edit it again. So instead of being that, we're going to be that, right? So we just took another byte off. What now? We're still doing out-of-bounds read there. Okay. This we're looking at now. I always forget that I can't do that in we're doing a pop pixel hex digits. So if we come up here, this is a very large file. Okay, so we have write PS image. Interesting, there's just this inline PostScript prelog, but okay. So I'm curious what we're overflowing. Are there more details in here that we can take advantage of? There are, aren't there? So this tells us memory access at offset 2752 overflows this variable. Interesting. So one of the things we can do here, we've got a couple options of how to go forward here. We verified that this is reachable. So we verified that we just wreck the stack. What we need to do now is we need to figure out why we're still crashing. So we're actually crashing prior to doing anything. It's worth noting that we are just wrecking the stack here, which is important. Like, we take a look at this, like, oh, I don't have it up now. We are just completely destroying the stack. So we've got, is this gonna work? I'm never sure how much GDB actually gives us. Okay. trying to think of what the best path forward here is going to be. So right here is where we start just wrecking everything. So we have config followed by infinite zeros. Okay. Where did we say this was? Coders. PS.c. Weird. So it says that pixels is what we're going to actually be an out of bounds reader write on. Scale relative to dots per inch. So we can only have have anything in it right now? It does. How convenient. So we got our page bounding box. Display image. Image columns, image rows.
All the things that could go wrong, or all the things that you wanted all along. And I don't really mind if what I say pisses you off. I never said I would take your side. I just said I would compromise. If you make me put up a fight, I'll fight back to the day I used to.
So we have this. And then this is where we're actually going to crash in here. What does that crash look like again? Interesting. So in this case, we've definitely triggered the same. We triggered something slightly different, right? Yeah. Okay.
Forget about the past mistakes. Cause all
Okay.
you ever did was change. And I hate being with you, but I just cannot be alone. All the promises you break, you get me out of this.
So, the theory here is, if you remember looking at this, pixels has 2048 bytes in it. So I think if we just make this x by y, so we did here is we made x by y, the y is now, we're replacing the y here. So this should not crash. Helps if I reset it. Yeah. Air's out, but it doesn't crash. Interesting. Should mark this off.
Forget about the love we made. Forget about the past mistakes. Cause all you ever did was change. And I hate being with you, but I just cannot be alone. All the promises you break, you get me at a distance, babe. Now I don't wanna see your face, but I hate being.
Apparently, need to make this much bigger than I was expecting. What have I done? This I could have swore caused crashes. Okay, I've screwed this up at this point. Not sure how, but I managed to screw this up. I'm probably changing the wrong field, aren't I? Okay, okay, that crashes just fine. Yeah, I think I screwed something up at some point because notice how 69 lines were filtered, and before I was seeing 95. I must have just screwed something up. Okay. Interesting. So what we're doing here, right, is we're kind of just going through and seeing, okay, it doesn't crash here, does it crash here? Interesting. This is a different error that was... So at the smaller sizes, we were getting this error. We're now getting this error. But we're not getting our overflow yet. Okay, so this just did the 95 lines thing, so we've screwed it up again. So FFOF is going to be just under what we were seeing cause the crash before. $10.99, $10.98. Two options about how to go forward here. Kind of just poking at this isn't giving me quite what I want. Like I can keep going back and forth and back and forth and back and forth like this, and eventually we're going to end up with close to what I want. But like we're just basically doing binary search at this point. The alternative here is we can actually get a real debug environment set up so we can actually debug it properly. Okay, let's do that real quick. I don't remember how to do this, so GDB... Okay, so I need to do this. So what we're going to do here is we need this right here. So we can do gdb utils.libs magic set environment that set args convert this. Okay, got the crash like we wanted to. We want to breakpoint though. We want to breakpoint on. What's this thing called? Okay, so here we're broken in. It's actually working better than I was really expecting. And the place where we're actually going to crash is 2232 on a pop hex pixel. So, interesting. Yeah, we're just getting this constantly, aren't we?
Government is the problem.
So this thing's gonna get called a whole bunch, isn't it? So it's before it sets up all the arguments. It annoys. Oh. Okay.
Government is the problem.
Trying to figure out what exactly we're going to do here, because we need to figure out what Q is. Do we? We're somehow getting a segfault inside of this, which is where again? Okay, so pixels is the last thing passed in, and we actually change what's in it. So we read in our pixel. What's this comment? So hex digits is an array that's being passed in. It pulls out the hex value. It increments it once. It's incrementing what's actually in hex digits, right? Yes. No. It's basically changing 2 pixels in pixels and returning it. Okay. So and at some point this is going so where's the actual out of bounds right happening? For Y to image rows, we're going to do this every time, aren't we? And for every column. Oh no, this is what we expected, right? So we made this many rows. So we're going to iterate through this every time. And because up here, Q is going to be pixels, we've gone well outside of the bounds for pixels. Okay. We've got pixels here. So we know that eventually we're going to smash this. Where's our cookie in here? Here's our cookie. So if we take this, interesting. So if I'm reading this correctly, we don't need anywhere near as many pixels. If I'm reading this correctly, if rows is much lower, we should eventually kill that. Okay, so I want to do a... Is it a watch? Yeah. Okay. did I screw this up again? I screwed this up again. Okay.
Running full
I
system
don't know how to do
diagnostics.
this.
Machine status fully operational. System online. All stations are now enabled. Target dog resistance. Operation overkill.
Trying to think of what to do here, right? So we do need to figure. So there's a couple pieces we need to do here. Well, we have this. We have this kind of. It's not actually the crash they're getting, but we're also doing that. We're looking around the stack. So there are some pointers just before this. I think. Yeah, let's check this one off.
Operation overkill.
So there's these pointers that are just before the stack cookie that we can overflow. And we'll be able to overwrite those. So if you overflow those, we may be able to do something interesting that way. Which would be good. Although,
Go ahead.
where is this again? 4. We're writing actual hex digits, aren't we? This may be quite awkward, isn't it? There's a non-zero chance that what we're actually going to be doing here is writing hex digits over a pointer, which might not be entirely exploitable. Yeah. Okay. We made some decent progress, I think. So I think at this point, we've made some decent progress, right? We built this in WSL and Ubuntu. We verified the crashes in both of them. We verified that while the crash that's happening in the report is not a stack cookie, we are smashing a stack cookie. And so when we there is one in place that's going to cause problems for us if we decide we need to do that. However, looking on the stack, there are some pointers between the buffer we're overwriting and the stack cookie. So it's possible we're going to be able to do something with that. The part that's going to be really tricky, though, is that we're writing hex bytes here, not real bytes. So it's possible that even controlling this properly, we're still not going to be able to do anything. Even if we make a bunch of assumptions, this may not be exploitable. But we'll see. I think the next steps here, we're going to open this up in Ghidra so we can actually take a look and get out where a lot of these things on the stack actually are. There's a way to do it in GDB, but I never remember how to do it, and we're probably going to want to have some disassembly to go through anyway. So we're going to pull this off, we'll look at it in Ghidra, and with that, we should be able to pretty easily figure out, oh, here are what those pointers are. Is there any way we can actually use them before we hit the stack cookie? Because that's what we're ending up with here, right? Do I still have this open? I do not. Run it again. So this is pixels, which is where we're going to end up writing a bunch of crap in. And we're going to be able to control all of this. But eventually we're going to hit this right here, which is a stack cookie. Once we hit this, we lose. Means that if we ever return from this function that we're currently in, we're going to get that abort and we're going to fail. Hopefully, though, these are all pointers. Hopefully they're actually real pointers and not just uninitialized memory. If they're uninitialized memory, this is going to be tricky. But if they're actual pointers that are getting used, well, we can modify them at least. We'll be able to do like low byte overwrites or something. And hopefully that's going to let us do something. I don't know what yet, but hopefully it's something useful. So at this point, I think we're going to wrap up this chunk of it. We kind of had a good discrete segment here. We got to the point where we verified this is a thing. We have a few hypotheses about how to move forward. We have good plans for next time. We're going to jump into the reversing portion of this. We're going to actually look at the binary and see what's going on, because while we do have the source code too, at some point we need to actually look at what's going on rather than trying to figure out from the source what's going on. Looking at the disassembly is going to be a little bit easier here. So yeah, hopefully this has been entertaining. It's a little bit different from the normal recordings because I'm not talking directly at anyone, so I'm talking a little bit less. So it comes out working a little bit differently. It feels a little bit different for me. But hopefully it is still useful for everybody watching. So until the next of these, I will see you all later. Bye.